So this lesson is going to look at statistical testing, and there's only one statistical test you're going to have to do in the exam, and that's called the sign test. And we're going to look at how you conduct this and all the key words associated with it. The first thing to understand is why we use statistical tests in psychology. Well, what we're trying to find is whether a difference between two groups is actually significant. So we might have the results for a study. So does an energy drink make you speak more words compared to drinking water? We found that there is a difference between the two groups. However, we use statistical tests to find out if that difference is significant. Is there a significant difference between them, or is it just a slight difference that makes no actual difference at all? So we use a sign test when we've got a study using repeated measures, we're looking for a difference between the two groups, and we have nominal data. So remember, nominal data is where the data can be in categories. So we've got all this in the data, we've got repeated measures, we've got looking for a difference, we've got nominal data, we're going to start using our sign test. So probability is one of the key words that we're going to be looking at when doing statistical tests. And in psychology, we always use a p-value of 0.05. Unless you're specifically told otherwise, in the question, always use 0.05. And what this means is that there's a 5% likelihood that the results are down to chance. So if your statistical test passes this 0.05 test, then you can be 95% certain that your results are down to you manipulating the independent variable. And if the results pass this test, this 0.05 test, then we can accept our hypothesis or reject it. And if it passes this test, then we can be 95% certain that the results are down to manipulating the independent variable, because there's only a 5% chance or 5% likelihood that the results are down to chance. And in psychology, that's a happy number for us to get. We're quite happy to accept 5% likelihood that the results are down to chance. Some other words you're going to hear when we're going through how to do the sign test are calculated and critical values. So a calculated value is the number you get from the results table. Okay, sometimes they'll give you the calculated value and they'll state next to it calculated value. That's the number you get from your set of data. The critical value, on the other hand, always comes in a critical value table. And this again will be given to you in the exam. You'll never have to work it out, but you'll have to work out which critical value to use. So calculated value is the number you get from your own results. A critical value is from a critical value table that is always kept the same. These two words will also be important, one-tailed and two-tailed tests. So a one-tailed test, you always use that when the hypothesis in the experiment is directional. Two-tailed test, on the other hand, is always used when the hypothesis is non-directional. In a study, they'll either ask you to write out a hypothesis or they'll give you the hypothesis. So you'll know straight away whether you've got a directional or non-directional hypothesis. And as a result of that, you use a one-tailed or a two-tailed test. Again, we'll start to use these words when we go through an example in a minute. So the experiment we're going to look at is to investigate if pupils say more words after drinking an energy drink, called speed up, or drinking water. And the hypothesis I'm giving you is there is a difference in the number of words spoke after drinking water compared to drinking speed up. So you can see straight away there's a non-directional hypothesis. I'm just saying there is a difference. I'm not saying if it's a higher, lower number. I'm just saying there will be a difference. So we're now going to go through it step by step, how you'd get a question in an exam. They might have given you that question and they'll give you quite a few tables that we're going to look at, and you've got to work out, is the difference significant or not? So if we have a look at this one first, you've got the results in this column here for speed up, when they drank speed up, and the column here for when they drank water. So for each participant, this first column, so we look at participant 1, they said 110 words when they drank speed up, they drank 120, or they said 122 words when they drank water. And it's got the numbers for the 20 different participants. So we just pick number 13, 134 words when he drank speed up, 157 words when he drank water. And what we're looking for now is for you to do this sign of difference column. You might be asked to do this in the exam. And this is where you take both columns and see if there is a difference between it. So this first participant, for example, said more words when they drank water. What was the second column? So they drank more words there, so this becomes a negative. We take speed up 110 and minus, we've got 110 and we minus the second column, 122. And obviously we get a minus number as a result of that. So we put a minus in the column. The second person, they said 59 words after drinking speed up, 45 words after drinking water. So we do the same thing, 59 minus 44, and we get a positive number. So we put a positive sign or plus in this column here. We do the same for every single participant. So we look at participant 6. They said more words when they were drinking speed up than they did with water. So we get a plus in that column. And you do that for every participant. Plus or minus, plus or minus, plus or minus. You always use this column first number, this column as the second number. So you've gone through your columns, you've done all your pluses and your minuses, and now it's time to add them all up. So if we look at our table, we got 13 pluses. So 13 people spoke more words after drinking speed up, and there were 7 minuses. So 7 people spoke more words after drinking water. And it's important here to note that if anyone spoke the same number of words in both, so when they drank speed up they might have said 50 words, and when they drank water they had 50 words, that person would get completely ignored. There's none in our table that we had. They were all plus or a minus. But if anyone did have the same, you would remove that person from the data set. So the next step is that you take the less frequent sign. So in our case, minuses were less. We only had 7 minuses, we had 13 pluses. And we call that number S. So we've got S equals 7 because we had 7 minuses, which was the least frequent. And this becomes our calculated value. Sometimes you'll have to work it out in exams, sometimes they'll give it to you. So the next step, once we know our calculated value, is we look at the hypothesis. Remember, if it's a directional hypothesis, we use a one-tailed test. If it's non-directional, we use a two-tailed test. And in our case, we had a non-directional hypothesis. So we're going to be using a two-tailed test in a minute. So now we've got to compare our calculated value with the critical value. And the critical value table is always used for this. You'll be given a critical value table in any test that this question comes up with. And remember, you always use P equals 0.05. And we had 20 participants. So N, which always stands for the number of participants, will be 20. So always use P equals 0.05, and N is always the number of participants in the experiment. So your critical value will look a little bit like this. And you can see this line at the top here says significant levels for a one-tailed test, and the next line down here says significance level for a two-tailed test. Right, we know we are using a two-tailed test. So you can basically ignore all of this top part of the information there. We don't need any of the one-tailed test because we're not bothered with that. We didn't have a directional hypothesis, so we're not using it. So we also know that we're using P equals 0.05. So we're using that column here. So we are only interested in the data in this particular column. So really, you could ignore all that column there, or both of those. You can ignore this first column here. We're only interested in the P is 0.05 column. So we also know that we've got 20 people. So we've got our N column here, number of people, and we've got 20. So what we do is we go along here and we look at the number that they cross at. So we've got our P is 0.05, we've got N is 20, and they cross over at the number 5. So our critical value for this is 5. Okay, if you had 13 people here, you'd move along at the number 13 and see what falls in that 0.05 column. So once you've done that, once you've got your critical value, which for us is the number 5, what you do is you read this little bit of writing which will be above or below the table, this little bit here. And for us it says the calculated value of S, so the one we've already got, must be equal to or less than the critical value for significance to be shown. And this sentence here is absolutely vital. Okay, so it says the calculated value, the one we've already got, so we had 7 was our number. the calculated value must be equal to or less than the critical value, which is 5 for us. So we know that 7 is greater than 5. So we can say the results are not significant because 7 is greater than 5. So we've looked at both of our tables now. We've got our calculated value, we've got our critical value. Calculated value is 7, our critical value is 5. So the next step is to look at how we put this into an answer. So the critical value we know for the sign test is 5. When n equals 20, so 20 participants, and p equals 0.05. And remember, this is when the original hypothesis was non-directional. So we use that two-tailed test. But remember the table said the calculated value must be equal to or less than 0.05 to be significant. And as 7, our calculated value, is greater than 5, we can say that the difference between the groups is not significant. If our calculated value was a lot lower, let's say our calculated value was 3, then we could have said our difference was significant. But because it was 7, which is greater than the critical value of 5, we can state that the results are not significant. So how do we report this in our answer? They might give you the table to go, right, work out if the difference is significant. And how you would write this up is, the difference is not significant because the calculated value of S equals 7 was greater than the critical value of 5, when P equals 0.05 and N equals 20. So that would get you your 3 little marks in the exam, maybe 1, 2, 3. Okay, and if you're still not understanding this, write down any questions, write down when you'll get stuck, and we can go through it in the class next lesson. Because this is a slightly trickier part of doing the statistical analysis.